Just a little bit about me. I'm, as many of you may have seen on the cover slide, I'm working for Airbus as a software engineer. At our location, we've founded a JAG, the JAG Bodensee, and I've been active in the Apache NetBeans community and acceptance testing. And lately also at the JCP in a minor role. So what I want to present to you in this talk is some small ways on how to use the monitoring capabilities that JFR and JMC will provide you. For that, just a little bit about what we do at our department. You will probably see as we go further on, it's not directly something about Java performance tuning or something like that. It's we're doing the radar upstream ground segment and payload data processing. So just a little advertisement up front. We do the communication and the processing for some satellite data, radar-based Earth observation and stuff like that, from analysis and design of complex systems to turnkey systems in between, some coherent engineering for systems, including end-to-end verifications, like designing the sensors and testing them once they are deployed. Some crypto and security engineering, so you got your system flying around Earth, and you want to make sure you're the only one talking with that system or getting its data. Some operational data processing, so the image analysis of the pictures and data the satellite may produce, and all of that in a agile process. So enough about that. Onto the actual topic. I'd like to start off with a small show of hands. Who has heard about JFR and or JMC and used it actually? Okay. So a small part has actually used these tools already. A lot of you have already heard about it. So what I want to throw in is a small introduction into both tools and tool suites. And after that, well, have a little fun on the command line, building a small UI, integrating it in a favorite IDE, and well, we're software developers. What do we do if we create new algorithms? We have to test them. So let's go on. So JFR and JMC, what is it? In quintessence, it's a tool suite for the JVM. It's consisting of the JDK flight recorder and the JDK mission control, and supposed to help you in finding problems, analyzing them, and optimizing your program running on applications and on the JVM in production. It's originating, or both tools originated from the JRocket mission control as a part of the JRocket JVM distribution. It started out at Appeal Virtual Systems, a Swedish company created by students here at the Royal Institute of Technology in Stockholm. I thought it was interesting to get that information across. Actually, here, being in Stockholm, talking about that instead of being in San Francisco or Las Vegas this year or whatever. So after a series of acquisitions from Appeal Virtual Systems through BIA systems, going to Sun and later on Oracle, it was made part of a commercial feature which was distributed up to JDK 10 in the Oracle JDK, and with JDK 11 open sourced as both tools as well as sources as part of the Open JDK project. Part of the open sourcing project process had to do with a rebranding of both tools. They were originally named Java Mission Control, which is a trademark problem with Oracle. So the naming was changed to JDK, Flight Recorder, and Mission Control, which is actually quite nice. You can keep the abbreviations of the tools. Flight Recorder. Flight Recorder is, in essence, a event recorder, and very similar to flight recorders you may have heard are on airplanes and stuff like that, which also has the benefit of having the recorded data even after the crash. So it is a low overhead system that can be always on, will monitor the runtime and some profiling and gather some profiling information in the JVM. It is also designed to minimize the observer effect. So the observer effect is the effect that by observing a system, you change what you're observing, like. Not quite dissimilar to if you would write some debugging information and some debugging breakpoints and call some methods that aren't part of the actual runtime. So, which can then cause some runtime effects that wouldn't even be there on at the regular production time, runtime. It is able to manage multiple recordings. So you can start some recordings delayed from when the application starts. Like if you do know that on Fridays at 9 p.m. your system gets kind of slow, so you can start a recording at 8:30 and have it run for like 2 hours, write onto disk the file, and once you come back on Monday, or if you so want, check on Sunday the recording and have a look at what was happening at that time. The low overhead part, the design aspect of that was to aim for a overhead of 2 to 3%, which is actually quite nice if you compare it to runtime instrumentation of when debugging or profiling, which is kind of very expensive if you take into consideration the recording of stack traces, which will require running on save points in the JVM, which has to have all threads stop at a save point in order to get these stack trace and stuff like that. In Flight Recorder, that is inbuilt into the JVM. It takes some lower overhead recordings of these information, but not only of the JVM, but also the application running on the JVM. Which brings me to what's in a recording. So the recording itself is a accumulation of binary chunks of data in a binary format, which is highly space effective due to some memory saving features, integer compression, and stuff like that. Each chunk in itself is self-describing and self-contained, so any information each chunk will have to wants to show, like constant pooling, like command line arguments or whatever, is contained in that chunk, including the definition of the data types. So each chunk can be analyzed by itself. The efficient storing, excuse me, during runtime, it's in a, as I said already, it's in a binary format, stored in a ring buffer. So after a certain limit is reached, the latest chunk is removed, a new one is added. Kind of like that. Mostly it's also on a thread local storage. You can have it stored on disk. Some studies have been made into other formats, like changing the binary format into JSON was like 2 magnitudes more space consumption, which is kind of bad, especially if you want to have the low overhead. So, getting at the recordings, you've got multiple ways. First of all, you've got the command line options. You can have for your you can set during your application start, like with the -XX start flight recording. You can also start recordings with the JCMD command utility of the JDK, JRE, or even via JMX, start some via JVisual VM or JDK Mission Control. Right. Switching over to JDK Mission Control. It is, in essence, a analyzation, or it's mostly used for analysis and visualization of JFR recordings. As I alluded just now, you can also start recordings and stop them and read them from via, among other things, JMX beans. But the analysis part is a really extensive part, the biggest part of the application. So not only showing what was on the recording, also some analysis, some rule application, reporting. Yes. Currently, it can be retrieved from the Oracle Tech Network. What it also provides is a set of APIs, which lets you, which enables you to read and process these JFR recordings. The artifacts, unfortunately, aren't available from Maven Central, although they have been made available through the OpenJDK repository hosted by JFrog. Right. In this session, I'm gonna skip over showing JMC recordings by using JMC. Due to the hopefully somewhat fun part about building your own analysis of the recordings, displaying stuff like that, coding stuff. And with that, switching to the command line. I hope that's big enough. If not, we can surely increase the size. So, command line is, we can use the JCMD command. without any parameters, it will list the running Java processes. If you add the process ID of the task, of the process, you can see that I can do some JFR stuff as well. There's pretty good documentation about the usage of JCMD and parameterization of these types. So I could go in here, but I'm gonna skip over that due to the extensive documentation parts. What I actually want to show is using JShell to run and analyze these recordings. A few years ago, a colleague of mine talked with Marcus Hirt about exactly this and the troubles he had about using the JFR APIs that the flight recorder APIs that the JMC project provided, and the problems he had during bootstrapping JMC. So at JCreate, they did some hacking, on that, and they came up with the project JMC shell, and essentially it is a wrapper around all this bootstrapping of JShell, so all the classes of JFR are available during runtime. What I just did with the OpenJMC part is preload some scripting parts into JShell, which essentially just loads some imports so that I can loader toolkit, load events. Then I can just load a recording file I have. Users marked in my recording. What was it named? Oh. Small r. JK11.jfr. So that's when the JFR loader toolkit is one of the APIs provided. So you do get a iterable, well, a event collection. Event collection. So what's that? What's in there? Let's have a look. Mr. Brace. So it's a collection of event type entries, and if we have a look in there, we will see that there is a event type entry for each type of JFR event that can be fired, including definitions about which attributes are there, what types, and if the collection part even has some events, you will also have the information about the items, what's in there. But that's one part. It's only looking at the type, finding out what the API does. So I could go into creating a report here as well, but let's just do it. Do it in this big enough, I hope. No. Do it in the IDE and use some small API, some small application, so a small JavaFX application, which loads the recording file. I just loaded in JShell, and lets it create a HTML report, which I could have done on JShell as well, but looking at a HTML string in a console isn't really that funny, that entertaining. So let's just run that in a application that can show the HTML. So pops up small, but we can increase it. So that's the analysis of a recording I just did prior to the session. Well, my memory isn't that full. I only had my 15.2 gigabytes. 95.2% were used. The stack depth is too high. Metaspace, live set trend was constantly increased. Well, it was a 2-minute build. And then the process was terminated. So loading stuff, caching it, that's part of the process. But for a production run process running for days at a time, this would be bad. It would be an indicator for a memory leak or stuff like that. So the report here is a visual representation of rules being applied against the recording, and combined with some value attributing good, bad, evil, stuff like that. There's by default the OK results are skipped, so you only have the bad ones, but you can also look at all the ones that aren't even bad. So you can see what all has been checked. Right. Okay. So this is more a simple UI, just using pre-existing stuff, that the mission control APIs provides you. If you want to do some more extensive looking at the data, like looking at the events by themselves, or some writing your own rules, that's also possible. The second demo I want to show here is I'm a NetBeans guy, so it's a NetBeans module that allows me to open a recording inside the IDE. Yes, it's too big to show in a text file, I know. I have to figure that out yet. But I got an alternate view with all the event types, also showing how many events have been there for that event. Including all the attributes of these events. I've got the G1 garbage collector with 172 events, so it ran quite a bit. There have been some GC pauses. I've got some. I got some integer flags for the process that have been set from the default origin. Should have some string flags. Yeah, and some exceptions. No demo without that. Yeah, here's a command line argument I had set for that process, so that I can get the recording in with the name of the parameter, the values, and it also shows the origin of that parameter where that has been set. There's the number of events, the types of events are quite extensive, so that always helps if you have all the information you need. So what I went through here is some JVM parameters the JVM uses to run itself and organize itself. It's got some, I've showed the garbage collection events. There's also, I don't know, CPU load, CPU information. There's I've seen my system information, what my operating system is. All that included in the recording. So all this helps to identify, hopefully, bottlenecks or problems at a runtime, at a process running over quite a while. Thank you. Right. But these are all the events the JVM comes out of the box. So JFR allows for writing your own events, which you can then write your own analysis or whatever you want. But how do you test that? Or how do you make sure that during your production, some certain events or stuff doesn't run, like you don't have the parallel GC running anymore, or whatever you like. So with that, I'd like to switch over to the testing part. Just have it run, and well, it's my demo, so it succeeds. What I've done is I've written a JUnit 4 rule. I know JUnit 5 is out there. We are trying to switch. It takes a while. JUnit 4 is still widely spread, so I started out with that. What I did is the flight recording rule, which will start a flight recording at the beginning of each test method being run. And after that, check some evaluations that are registered at test time. So like for example, I did some arbitrary create user event, registering. I'm registering a new user that has some first name, last name, has a certain age, has some certain what did I has some certain. As a super user, he's got some rating, like he's very capable, he's got he's very knowledgeable and stuff like that. And just registered some matches to check for these events on that. Now, my setup method only sets fires to the events, and these tests I've written are currently only checking that the first two work. So in adding a third user event will wrong demo. This one. Will then show some failures in the test because the assumptions haven't been met, like number of events thrown, values in the events and stuff like that. I'm just open the report, and after that we'll head over to the JUnit rule to show you how I managed that. Yeah. So 3 events should have been fired, 4 have been fired. Collection of a certain event should only have 2 events, and but has gotten 3. Some very simple checking. So the giant rule does some before and after, working before and after the test, including some at apply time of the rule, like registering the JMX, getting the JMX bean and starting the recording in there, getting the data out of the JMX bean, and reading the data, stuff I showed in the other demos already. Right. So JFR record, active recording, the managed bean, which I alluded to, and some I/O stuff to get all the data out of there. And actually with that, I'm running very fast. Maybe I could just switch over to some to the Q&A. Actually, I have to. So we've done the command line stuff. I put the link to the JMC shell in here. The standalone UIs, the IDE demo, and the unit tests. Right, the link there is from a blog post from Gunnar Morning from a few days ago about how best to write events for JFR, and some customization for the JMC UI as a plugin to get the analyzers in there. And with that, I'm actually too fast.
Should we take questions? Anyone? Otherwise?
Please. Mm-hmm.
Oh, sorry.
The question was about using recordings for doing testing, acceptance testing, integration testing, stuff like that. Yeah, the good part about the recordings is they are transferable. So if you have like your applications running in a cloud somewhere, you can have the recording and connect to these systems. So that's the production part. And during test time, you can configure your VMs such that they start the recordings automatically. With the low overhead, it doesn't really matter. Like 2 or 3% on a VM, it doesn't cost you anything. Usually, depending on the profile, what you run during the recording, it might even be below 1% of the overhead. So you can just have it on all the time. Connect to it, get the data out, and just let it run. The unit testing, integration testing, you can just have your business code run, and after that, evaluate. Well, in the unit test demo, I tried to show that thing, with the simple test. I'm just the fire events method is just a stand-in for a call into the business code, And then registering the checks I want to have, that number of events have been thrown and stuff like that. It can be extended quite a bit. It's a consumer. That's why the assert that is running here. So it's just a simple Java and JUnit checking for your expectations. I hope that helps.
Yes, I have a question.
Sure.
Hello. Yeah. Okay. So my question was regarding the visualization that you showed on the JavaFX application.
Mm-hmm.
Does JMC show the equivalent of that
It does.
in its client, or is that your application?
No, it does.
Okay.
Just let me start it. Well, with the time we can skip into that.
And another question, if I may, thank you. Are these the JFR recordings?
Mm-hmm.
Are you able to get these metrics and this telemetry in real time, or do you need to run it in a sample, extract the JFR recordings, and then visualize them using JMC?
There is on the GraalVM OpenJDK project, there is the fork of the JVisual VM has I think that's the JSR 407, the JFR streaming APIs, where you can just connect to it and get live events directly out of it. But it's directly the events. You will have to have some evaluation of these events after the fact or on receiving, and you can even filter for certain events there. So you just register for events A, B, C, and you will only get those. The JMC analysis usually starts off with this overview site. You can enable all the good parts, rules that have been good so far. Have some garbage collection, graphical analysis there. It is really quite well, and displaying all the data in there, including some, I think some flame graphs are in there, or there are some discussions about on the mailing list about getting flame graphs in there for the analysis of the exceptions and stuff like that. What paths? There's quite a lot of active work going on in that direction. Pleasure. Anyone else? Going once, going twice.
Thank you, everyone.